Good day, everybody. This is the March 15th, 2026 moderate risk update for the East Coast. Really, anywhere from New York all the way down to Florida is in the storm's track, and it's going to be very violent. It really significantly upgraded overnight. So we have a long, in-depth video discussing what's going on in this outbreak, because it's going to be a bad one. You can see in this graphic, you're getting a QLCS line. Well, in this case, it would be a derecho. Now, what is a derecho? It's a line of strong, straight winds that travels for at least 200 miles and brings over 60-mile-an-hour winds that entire area. Looking at this, in front of it, you can see supercells. And some of those rounder ones, they are hailstorms. And the ones that look like kidney beans and have like a very strong or very high precipitation rate on the bottom, it's a tornado. It's a supercell, a tornado-producing supercell. You'd be like, though, why is there that high precipitation not at the bottom if there's not really much precipitation by the tornado? And yeah, there's not much precipitation by the tornado, at least compared to the hail core, but the damage of the tornado generally gets picked up on radar, and it generally looks like the correlation coefficient, but sometimes it's also seen as precipitation, which is very dangerous. So I just wanted to bring that up. On the backside, you're seeing light rain, maybe some thunderstorms, but we can see this in tomorrow's outbreak, but they're not anything severe. But you can just see the insanely high precipitation amounts in that QLCS, and that's just showing how intense this is going to be. And this is a pretty accurate graphic on what's going to happen. Heading over to the tornado probability, very high. Really higher than I thought it was going to be. I thought it was going to be around a 10%. 15% risk for anywhere from Washington, D.C. all the way down into South Carolina. And then you get the 10% risk all the way up from, let's say, Harrisburg down to Savannah, Georgia. If you're in this red or yellow area, you really need to start preparing for a tornado. However, if you are in any of these areas, you should. That's going to be the core of this tornado outbreak that we could get. And yes, I'm saying tornado outbreak. Like, you get this in moderate risk day outbreaks. And would you guess, it is going to be a moderate risk day. So it is going to be a very dangerous situation, and I highly implore you, just start getting ready for tornadoes. And even if you're not in this tornado area, QLCS lines generally bring tornado force winds, and you should prepare for them like tornadoes. Alright, so anyway, the tornado probability stretches down the Appalachians pretty much. If you're east of the Appalachians, really anywhere, you gotta prepare. Anywhere from Atlanta, Panama City, even into Jacksonville, up to Scranton, Trenton, New Jersey. All of you guys really need to prepare for something. I could see this getting expanded east into the New York City area later on today. Due to the insane wind shear that's going to be happening. Wind shear values up to 75 knots are possible, and that's even in the SPC discussion. Could rogue areas, a couple thousand feet above the surface, approach 80 knots? Very well. But yeah, the absolute wind shear is going to be extreme, quoting the SPC, extreme values of wind shear. And this, in tied with very warm air and Gulf moisture, it's going to allow for tornadic formation. I do think a lot of these are going to form in supercells. The ones forming in isolated supercells could become very, very dangerous. Take Kankakee or Mayfield, you got the Quad State tornado, not like in 2021, it was a little bit ago. That was in a rogue supercell in a QLCS outbreak, and it absolutely ripped. The town of Mayfield was completely destroyed, and then furthermore towns down the line. Could we see something like this tomorrow? I doubt it, but it's always on the table. What I think is going to happen, though, is embedded tornadoes in this QLCS line, quasi-linear convective system, if I haven't clarified that yet. And those could be weak, but they are still tornadoes, and when you're getting 90-mile-an-hour winds next to that, it's going to be very dangerous, very devastating. But yeah, if you're in the DC area, really, in this outbreak, you're literally right in the worst place you could be in this outbreak. Heading over to the wind probability, really anywhere from Philadelphia all the way down into Myrtle Beach, you're in the most likely area for damaging winds. I could see 70, 80, even 90 mile an hour winds. 100 mile an hour gusts can't be ruled out on this quasi-linear convective system line. Really, it's because of that sharp boundary between the warm and cold air. And then it's going to be actually a very sharp gradient coming down from the Appalachians. The downsloping winds from the Appalachians are actually going to help this strong wind and tornado formation. Atlanta, all the way up into Binghamton. Even Ocean City, y'all could be getting also in some very nasty winds. However, it's not going to be as severe as what's going on in that core area that's super tight. But if you're in this 5% area, 10% area, even if you're not even in this area, if you're just nearby it, you need to prepare for strong winds. Boston, you're not in this area. I do think you could be getting some gusty winds overnight, so obviously prepare there. New York City, you're in this area. You need to prepare as well. Buffalo, New York. I don't think a lot of people are talking about you. You are going to be in an area where I do believe there's going to be a slight bit more inflow than other areas, so it could allow for much more significant winds to come through the area. Heading over to the hail probabilities, you're getting hail anywhere from Scranton, Pennsylvania, all the way down to Orlando. West Palm Beach, you're in this area as well. You're getting a hatched area in North Carolina, South Carolina, and all the way down to Florida. Georgia, you're in this area as well. Savannah, Charleston, Myrtle Beach, Raleigh, Durham, Jacksonville, you're all in this area. And this is just showing the probability for large hail. Gorilla hail is not off the table, although very, very unlikely. So I wouldn't be worried about gorilla hail. But the greatest hail probability is anywhere really from Richmond down into Panama City area. However, if you get hail as far north as Scranton, Pennsylvania, for example, and as far south as West Palm Beach. However, if you're in this 5% area, I wouldn't be too concerned. It's not the main risk. You have bigger fish to fry. For example, I mean, you're dealing with the wind and tornado threat, so I wouldn't really be too concerned about the hail threat. However, just a spice on top of the dish on what's going to happen. Alright, so now let's look at what happens in a cold front. And this really shows the storm formation. So, at the bottom of the storm, you can see the cold air, and it's coming in. You can see the lower level winds here. And you're going to get some low-flying clouds, and that's generally why behind cold fronts you get fog before high pressure moves in. And in front of it, you're getting warm inflow, and that's because the cold air is literally making the warm air launch, and this makes it go up, and that creates an updraft. And along with the moisture, if there's moisture present, the cold air is going to allow it to condense, and that's when you could get these very high top clouds. Normally in front of a cold front for like 300 miles, you're going to get a lot of stratus clouds, but as you're nearby, they're going to turn into cumulus, and then you get the cumulonimbus clouds, which are your thunderstorm clouds. And if they start rotating, then it's a problem. Over on the left of this graphic, you can see wind. That coincides with winds here. If you get really strong valleys like we're going to see tomorrow, that's when you get tornadoes. Now let's go into a hail-producing thunderstorm. This is really for the people in the southeast, this graphic. You can see the warm updraft. You'll normally get that. If you're in a supercell, you're going to get that in your dry slot, right to the north of the Hook Echo generally. And yeah, it travels up the updraft, the hailstone, which at this time is going to actually be liquid water. Once it reaches the top, then it'll freeze into a hailstone and start falling. And then on the backside, you're going to get a cool downdraft. That's going to make the hailstone fall. And if it's strong enough, it's going to get to the ground in time and not melt. It's going to become a hailstone. And depending on how cold the thunderstorm is, and how much water collect on it, it could grow and grow and grow into what meteorologists call gorilla hail. And that could be very devastating. I know a lot of people tracking the tornado outbreak out in the Midwest a couple days ago got hit by this 5-inch hail. I know the Illinois state record was nearly broken, if not broken, by 6-inch hail. But a lot of the storm chasers' windshields got absolutely destroyed. I mean, it cracked, and they're going to need repairs. But you got to really be careful about this hail. You're going to get large hail and small hail just depending on how strong these storms are. However, it's not the main risk. But it's just something not good to know, especially in this type of outbreak, especially if you're in the southeast, however. Here, let's look at a tornadic thunderstorm. I feel this is going to be more relevant to the outbreak. Right now, you can see low-level winds behind this self, you could say, because generally, in front of the hill court to the south, nearing the dry slot, you're going to get a self cloud, as they call it. And this self cloud is going to bring strong winds, hail, and very heavy rain. And that's normally why you can't see lightning in these storms from far away, because the rain actually blocks out really any light from escaping. You're going to get a flanking line that's kind of where you're going to get the self cloud. And then you get mid-level winds. They're going to feed into the downdraft. And that's where you get a rear flank downdraft, and that's going to spin around the main updraft. And that's when you can just start getting rotation. The main updraft goes really high into the clouds. High-level winds support this rotation, and that's when you could get a tornado beginning to drop down. That's really a funnel. It's really rare for a tornado to touch the ground, but when it does, you're going to see the wall cloud, and you're going to get a condensed funnel. A condensed funnel, it's generally going to be very small. That's why I'm calling it condensed. It's like only maybe 300 feet across at most, generally. However, if it gets wider, that's when it can really start ripping. You get the central downdraft that's going to feed the tornado and allow it to spin, while you're going to get the updraft feeding around this main downdraft. And that's going to pull up dust, in which this graphic is calling a dust shroud. But it's going to really allow for a tornado form. From the core of the tornado, or I shouldn't say core, coming out of the Hulk Echo, you're going to get the surface inflow layer, and that's just going to continue feeding that tornado, and that's how it could really get strong. Now let's look at a QLCS line, a convective, quasi-linear convective system. Jeez Louise. And you can see you could get a tornado. It's rare. I shouldn't say rare, but it's not unheard of, but it's uncommon. And you can really just see the bow echo, they call it. It's really where it's just such a steep rate, because behind it you're getting such strong winds, and then in front of it you're getting the inflow. It's keeping the precipitation out. It's like a door. You open the door, you're in a room with insane precipitation and very strong winds. But if you leave the room, you're in some of the calmest conditions that you're ever going to be in. And that's literally how a quasi-linear convective system works. We're going to be seeing a lot of these tomorrow. What I do find interesting in this graphic, though, is it marks the outflow boundary. You could see the outflow, and sometimes that comes out like a gunshot. You could almost see it on radar, and it travels like 50 miles. And that's from the downdraft weakening and then re-strengthening. The downdraft is literally making the radar think there's precipitation. It's really cool. Regardless, though, these storms in general are not cool. They cause severe damage. These are some of the most damaging storms you're going to get in an outbreak, and unfortunately, it's the main concern of this outbreak. And these can produce winds upwards of 100 miles an hour. To say gusts, not really 100-mile-an-hour winds. Generally, winds would be around 70 miles an hour in these storms. But some of these guys really, I believe there's 124-mile-an-hour wind gusts back in the Iowa derecho. I keep bringing up the Iowa derecho in these videos, but that's because this outbreak is very reminiscent of it, except it's in a different location. That's all. It's going to be a derecho, and these guys bring really strong winds. Now, what is the difference between a tornado watch